The second question, it is asking, find the expectation value of x. The second question is, find the expectation value of x. Now you know how to write the expectation value of x here, and then from, okay, over here you will have to, this is the general condition, and now according to your geometry, this will be from minus a to plus a, and sine mod square dx equal to 1. Because your wave function is defined in this range only, elsewhere it is 0. So it will be from minus a to plus a sine mod square this. Expectation value, it will be again from minus a to plus a, and sine conjugate and x and sine and dx. So I hope this is very easy to calculate, and we have already calculated expectation value of a comparatively difficult integral, so you will do this by yourself. The third question, and this one is, which is part C. What is the expectation value of P? As we have done momentum now, so we will do calculate this one. What is the expectation value of P? Now I know that I can write P here like this as well, from minus a to plus a, and sine conjugate, and then the momentum operator and sine and dx. So I can write this one, that P will be equal to minus a to plus a, because those are my limits. And what about sine conjugate? Sine conjugate will be the same, a into a square minus x square, and then P is minus I h bar curly over curly x, and sine is a into a square minus x square and dx, right? So it's very simple integral. You can very easily solve this one. So let's start here. This one will become a and a here. This will become a squared. And now I can take minus I h bar common from here, means take it out from here. Then a square minus x square will come in this integral. This is a square minus x square. Now what about this one? When curly by curly x operates on this, a square, it will become 0, while this will become minus 2x. So this will become minus 2x and dx. Let me rearrange this more so that it is much clearer. This is minus 2 will come out, so it will be 2a square IH bar, and then integral from minus a to plus a, and it will be x into a square minus x square. Whenever your integral is final, so always check one thing. Don't go for the solution of the integral. Always do the odd even check of the integral. Because if you will solve this one, you will get the same answer. Or if you do the odd and even test of it, you can do it in one step. These are two functions of x. Look here, this is an odd function, and this one is even function because it is x squared. If I change the sign of x, it will remain the same. So it means it is a combination of odd and even function, and the limits are even here, minus infinity to plus infinity. So this will always give you 0. Right? So this test you will have to do always. Whenever your integral is simplified, always do the odd even test, and this will save you a lot of time. So it says that the expectation value of the momentum is equal to 0. Now the next question, it is asking, the fourth question it is asking is, find the expectation value of x squared. Find this expectation value. Now I know that what will be this one, x squared. It will be from minus a to plus a, and psi conjugate x squared sine dx. So you will have to solve this one as well, as I have already done the x squared in other problem. The fifth question which is asked is, find the expectation value of p squared. Now I know that the expectation value of p is equal to 0. So the expectation value of p squared will also be 0. It is not necessary. So always do differentiate between this thing. The expectation value of p squared is not actually this thing. What's the difference? This is the expectation value of p squared, and this one, this is the square of the expectation value of p, right? So these two are completely different things. Don't mix up these two. So I will have to find p squared, and for p squared I will write that from minus a to plus a psi conjugate. Always write the formula for yourself. Do step-by-step simplification and you will never be lost. So minus I h bar and curly over curly x. This is the value of p squared. And then psi and then dx. So now I can further solve this thing, and this will be, put the values in here, and what will be this one? This will be p squared equal. Now minus I h bar whole square. The very first thing, do this one. Minus square is plus. I square is minus. So it is minus. And h bar square. And then from minus a to plus a, and psi conjugate and curly square by curly x square and sine dx. And this thing is equal minus h bar square, and from minus a to plus a, what is psi conjugate? It is the same, a square minus x square, because there is no iodine involved, and curly square by curly x square. And what about psi? It is a square minus x square dx. So this is equal to minus h bar square. A square will get out, and from minus a to plus a square minus x square. And now apply the derivative on this one. When curly by curly x will apply on this, it will make this thing minus 2x. When it will be applied again, it will make this minus 2. So you got minus 2 here. And this dx will come in here. So you got minus 2 will come outside, it will become 2 h bar square a square. Integral from minus a to plus a square minus x square dx. Now I think it's a very simple integral. A square x will come, because when a square dx, so it will become a square x from minus a to plus a limits, and then this will come x cubed by 3 from minus a to plus a, put the limits. So it is a very simple integral, and you will get for this. Another thing you can do, you can simplify further this one. When your integral is simplified, don't forget to do two things: the odd even test and the symmetry test. Look here, it's an even function. An even function, so the limits from minus a to plus a you can convert from 0 to a with multiplying by 2. Like for an even function, this will come out to be 4 times h bar square a square, and this will become 0 to plus a, because minus a to plus a and f of x dx is equal to 2 times 0 to a, means plus a, f of x dx, provided this one is an even function. So you can write this for this in a square minus x square dx. You can put the value of a from here. So a square will be 15 by 16 a square, and finally you will get that the expectation value of p square is equal to 5 by 2 and h bar square over a square. This will be the expectation value of p square. And now some more things are asked from you, like in part 6, sigma x is supposed to be calculated. So what will be sigma x? Sigma x will be the square expectation value minus x and the square of it. Similarly, in the 7th question that you can calculate, in the 7th question sigma p is asked to be calculated. So sigma p means the standard deviation and momentum will be p squared expectation value minus the square of the expectation value of this. So this will be what? This I know it is equal to 0, while this one will come out to be 5 over 2 square root and h bar over a, because this value is equal to 0. So I can write this one, the 8th question, which is asked to write the Heisenberg uncertainty principle and prove that this thing will always come out to be greater or equal to h bar over 2. But I will skip this one, means as I skipped the Heisenberg uncertainty principle because it is too early to understand that thing. So we will leave that thing to chapter 2 and 3, and over there when our knowledge of the quantum mechanical operators will complete, then we will do that thing as well. Okay? Thank you.